Hi friends, welcome you all to Vetrii Engineering Academy. So in this lecture we are going to discuss about the viscosity, so which is one of the important topic in fluid mechanics subject for both civil as well as mechanical engineering students. So friends, நிறைய competitive examinations la, so examinations like GATE examination or TNPSC examination or SSC JA examinations, questions are coming frequently from this topic. So to score good marks, so we need to have a clear understanding about this topic. So let us discuss in detail about this topic, right? Yeah, what is viscosity? So what is viscosity? So in order to understand this, so let us take a small example. Okay, so here I am taking a vessel and taking another vessel. So in this, in one vessel I am taking, what is this? Honey. The other vessel I am taking water, right? So then what I am doing, so I have taken a small metal ball. I have taken a small metal ball. What we are doing, I have taken two vessels in order to understand the viscosity. In one vessel I have taken honey, the other vessel I have taken water. Take a small metal ball and just drop the ball in vessel containing honey and also vessel containing water. So what is that we can able to observe here? So what is that we can able to observe here? Supposing that at time t is equal to 1 second, the ball is here in honey. At time t is equal to 5 seconds, so the ball in this vessel may come here. Okay. The same time, if you are able to observe, at time t is equal to 1 second here, at time t is equal to 5 seconds. So in case of water, the ball may be here. So what is that we can able to observe? So in case of honey, the metal ball is moving slowly compared to water. So what it indicates? So in case of honey, the internal resistance towards the motion of the ball is high compared to water. So we can say honey is more viscous in nature compared to water. Then what is viscosity? So what is viscosity? As per definition, if you are able to see here, it is the measure of internal fluid friction which causes resistance to flow. The other way of defining this, it is the internal resistance against the motion of two adjoining layers. So layer 1, layer 2, the internal resistance against the motion of two adjoining layers, also called as viscosity, right? So in order to understand this, let us take another example. So here I have given two diagrams. So case 1, case 2. So in case 1, this is 1, this is 2, case 1, case 2. What I have taken in case 1, I have two molecules, M1 and M2. So this is M1, this is M2, okay. M1 and M2. The mass of molecules is, I am representing with M1, M2, and then the distance between the molecules, is dy. Okay. So both the molecules are moving together and the velocity of molecule M1 is u meters per second, velocity of molecule M2 is also u meters per second. That means both the molecules are moving with same velocities. And also I have given here at time t is equal to 0 seconds, at time t is equal to 1 second, time t is equal to 2 seconds. So as we know, when two molecules are there, definitely there will be there will be attraction between the molecules. Okay, so this attraction here I have shown with F. The attraction force between molecules M1 and M2 at time t is equal to 0 second is F, which is a normal force. Correct? Time t is equal to 1 second, what is happening? The force is again normal force. At time t is equal to 2 seconds, the force attraction force is again a normal force F. So what is that we can able to understand here? When the molecules are moving with same speed, nothing is happening to the attraction force. Okay, so coming to the second case, here also I have taken molecule M1, molecule M2. So mass of the molecules I have represented with M1 and M2, and the distance between the molecules, again here it is dy. Both the molecules are moving together. Then molecule M1 and molecule M2 are moving with different velocities. So M2 here I am representing with moving with a velocity u meters per second, whereas M1 is moving with velocity u plus du meters per second. Yes or no? And then again whatever we have seen in previous case, just correlate here. So at time t is equal to 0 second, time t is equal to 0 second, the attraction between the molecules is F1, correct? Which is a normal force. At time t is equal to 1 second, what is happening? What is happening here? This is little inclined, correct? The force is getting inclined. At time t is equal to 2 seconds, what is happening here? It is getting further inclined. Yes or no? It is F1, F2, F3. What is happening here? Correct? This M2 is slow moving molecule. Correct? M1 is fast moving molecule. Yes or no? Fast moving molecule. So fast moving molecule is trying to pull forward the slow moving molecule. Correct? Fast moving molecule is trying to pull forward this slow moving molecule. At the same time, this slow moving molecule is trying to pull backward the fast moving molecule. Correct? So there is a differential movement between the molecules. So because of this differential movement between the molecules, a shear force has been developed between the molecules. So this was studied by Newton. Okay, so according to Newton, so mathematically, okay, so according to Newton, so this shear force T is proportional to du. According to Newton, shear force T is proportional to du. Du is nothing but relative velocity between the molecules. Correct? And also this is proportional to A. What is A? Area in shear. And this also is proportional to 1 by dy, or it is inversely proportional to the distance between the molecules. So if we rearrange all these terms, what will happen? T is proportional to A du by dy. Correct? Okay, rearrange pannalama. T by A, what is this? What is this? Force by area. Force by area is nothing but stress. So if I denote this stress with tau, this will become du by dy. So tau is, I can say it is shear stress. Okay, tau is proportional to du by dy. இப்போ நம்ம இந்த proportionality remove பண்ணதுக்கு we can able to introduce some constant. So if I introduce a constant, this will become tau is equal to mu du by dy. Tau is equal to mu du by dy. எழுதலாமா? இந்த மாதிரி எழுதலாமா? So what are the various things here? Tau enna? Tau is nothing but shear stress. What is mu? Mu is nothing but we have introduced a constant. This we can call as mu. Maybe mu is equal to coefficient of viscosity or dynamic viscosity. Coefficient of viscosity or dynamic viscosity. So du by dy, we can call this as velocity gradient, change in velocity over a distance, velocity gradient. So all the parameters I think you can able to understand now according to Newton's law of viscosity. So this finally, this I have to tell, this is nothing but Newton's law of viscosity. Very important relationship. So many times questions are asked from this relationship. So shear stress tau is equal to mu du by dy. Clear? Is it clear? Yeah. Okay. So let us see the kinematic viscosity. The other term. So just now we have discussed about dynamic viscosity in detail. Then what is the difference between kinematic viscosity and dynamic viscosity? So friends, in case of gases, the dynamic viscosity values are very low. So in order to do some calculations or do analysis for various types of systems, dealing with very small values is very difficult. So in order to overcome this, we have introduced the other term called kinematic viscosity. So as per definition, this kinematic viscosity denoted with nu. Kinematic viscosity denoted with nu. So as per the definition, this kinematic viscosity nu is nothing but dynamic viscosity by density, right? It is the ratio of dynamic viscosity by density. So how to write the dimensions for this? What are the dimensions? Very simple. For dynamic viscosity, just now we have written, it's nothing but m L power minus 1 T power minus 1, correct? Density is nothing but mass by volume, that is nothing but m by L cube, that is m L power minus 3. So what is left out here? M and m will go cancel, this is minus 1, so left out is nothing but, so this is L square T power minus 1. Dimensional formula for kinematic viscosity, many times again tests asked in competitive examination. Purida, what we are doing? So L square T power minus 1. So once we have written this, it is very easy to write the units. Yes or no? What are the units? Again CGS. What are the units? Length is in terms of centimeter, that is centimeter square per second. MKS, this is meter square per second. SI system also meter square per second. Very good. SI system also meter square per second. So please keep in mind this centimeter square per second is called as Stokes, name of a scientist. Centimeter square per second is called as Stokes. Similarly, 1 by 100th Stokes, 1 by 100th Stokes is called as 1 centi-Stokes. Stokes, many times again it has been asked. Okay, what is Stokes? Stokes is nothing but centimeter square per second. What is the unit of kinematic viscosity? Stokes, centimeter square per second or meter square per second. Okay, so this is about kinematic viscosity. Okay, let me save this. Yeah. Yes friends, yeah, I think the concept of viscosity, the Newton's law of viscosity, and then the units, dimensions, kinematic viscosity, everything we have discussed. So let us see few problems or questions asked in previous competitive examinations. Also this question is asked in GATE 2007. So what is this? What is this? So Newton's law of viscosity states that shear stress in a fluid is proportional to. So according to our formula, Newton's law of viscosity formula, what is that we have derived? Newton's law of viscosity, shear stress is equal to mu du by dy. This is what is Newton's law of viscosity. So what is that they are asking? Newton's law of viscosity states that the shear stress in a fluid is proportional to. So proportional means before arriving this one we have written this one like this. Yes or no? Shear stress tau is proportional to du by dy. Du by dy is nothing but our velocity gradient. So see the various options what they have given. They have given velocity of the fluid. No. Then they have given the time rate change of velocity of the fluid, that is dv by dt. No. They have given the rate of change of velocity of the fluid with the height of the fluid. Rate of change of velocity is nothing but our du with respect to dy. So the correct answer we have C. Last one also you see the square of the velocity of the fluid, you don't have any square term. So the correct answer for this is C, right? Next have, what is this one? Read this. What is this? Newton's law of viscosity states that the shear stress is directly proportional to, direct question, okay? Shear stress is mu du by dy. Similarly, shear stress is directly proportional to what they are asking. Is directly proportional to velocity, velocity gradient, shear strain, viscosity. What is that we have? Shear stress is directly proportional to, what is this one? What is this one? Du by dy is nothing but our velocity gradient. So the correct answer we have is B, right? Very simple. See, very simple question asked in Tnpsc 2014, right? Next, yeah, a small problem here. So asked in GATE 2004. Let us see what is that they are asking. An incompressible fluid of kinematic viscosity. Let us write the very small. Let us write the given data. Nu they have given as how much? 7.4 into 10 power minus 7 meter square per second. Okay. Next, specific gravity they have given. Specific gravity of the fluid they have given as 0.88 is held between two parallel plates. If the top plate is moved with a velocity of 0.5 meters per second while the bottom one is held stationary, what is the condition? They see here, bottom one is stationary, plate is moving here with 0.5 meters per second. 0.5 meters per second. What will be our du? What will be our du? The value of du is nothing but change in velocity, that is 0.5 minus 0. So here the velocity v1 is equal to 0, v2 is equal to 0.5. So this will become 0.5 meters per second. This is what they have given. Next, and the fluid attains a linear velocity profile in the gap of 0.5 mm. That is, what is the distance between these two they are given? They have given this is nothing but our dy. Yes or no? How much? 0.5 mm. The value of dy 0.5 mm, that is nothing but, if I convert this into meters, SI system, 0.0005 meters, correct. What else they have given? The shear stress on the surface of the bottom plate is, they are asking us to calculate the shear stress in terms of what? Pascal. So shear stress tau they are asking. Very direct substitution, yes or no? Direct substitution. What is that we have? Shear stress tau is equal to mu du by dy as per our Newton's law of viscosity formula. So what is what are all the various things they have given here? Check this one. Du value they have given, dy value they have given. What is unknown? Our interest is to get the value of shear stress. What is unknown? Mu is unknown. Mu nama calculate pannu. How to calculate mu? In order to calculate mu, what is that they have given? Kinematic viscosity kuduthirukanga. Namakku enna venu? Dynamic viscosity venu. What is the relationship? So dynamic viscosity or kinematic viscosity is equal to dynamic viscosity by density. So idhila we can able to calculate mu, that is kinematic viscosity into rho. Kinematic viscosity kudutitanga problem la. What is unknown here? Unknown here is density. How to calculate density? To calculate density, what is that they have given? Specific gravity. Very simple. So specific gravity, yes. Specific gravity, yes, of fluid is nothing but rho fluid by rho water, correct? Rho fluid by rho water. Substitute the values. So here I will erase this one, okay. So yes, F, how much they have given? 0.88 is equal to rho F is unknown divided by rho water, how much? 1000 kg per meter cube. So density of fluid we get as 0.88 into 1000 is nothing but 880 kg per meter cube, correct. So once we get this, calculate the value of mu, that is nu into rho, 7.4, this is nothing but 7.4 into 10 power minus 7 into 880. Please tell me the answer for this. How much we get? 7.4 into 10 power minus 70, 880. How much? 6.51 to minus 4. Okay. We got the value of mu. So once we get the value of mu, what is that we have to do now? So mu also we got. Our interest is to get the value of tau. So substitute all the values, very simple. Substitute all the values. Tau is equal to, we have mu into 10 power minus 4 into, we have du 0.5 and then dy 0.0005. What is that you get? Tell me the answer. 6.512 into 10 power minus 4 into 0.5 by 0.0005. How much? 0.651. That's all? Okay, 512. This is Newton per meter square is nothing but our Pascal. That's what they are asking. So answer for this, shear stress tau is equal to 6512 Pascal. That's all. Very simple. So ultimately with the given data, okay, direct substitution. Only small twist what they have given. So they have given the value of kinematic viscosity. We need dynamic viscosity. Once we know the relationship, we can get that. And also, in order to get the value of density, they have given the specific gravity. From that, we have calculated the density. Very simple. Correct? Okay. Right? Next. Yes, what is this? Read the question. Read the question. Which of the following fluids obey Newton's law of viscosity? So Newton's law of viscosity based classification of fluids. Already I think we have studied this. What is this? In y axis we have shear stress, x axis we have du by dy, that is nothing but velocity gradient or rate of shear strain. So once any fluid which obeys Newton's law of viscosity, we have seen, we have drawn the graphs like this, yes or no? So what is this? Newtonian fluid. What is this? Non-Newtonian fluid. Correct? So what it indicates? So any fluid which obeys Newton's law of viscosity, that is shear stress is proportional to rate of shear strain, that fluid we call as Newtonian fluid. Which do not obey called as non-Newtonian fluid. What is that they are asking in the question? Which of the following fluids obey Newton's law of viscosity? Where is the answer we have? Which is the answer? C. That is Newtonian fluids. Very simple, direct, very simple. Okay, when 2019 Tnpsc AE, very simple. Okay, next have okay 2018 Tnpsc. What is that they are asking here again? Dash is that property of a fluid by virtue of which it offers resistance to the movement of one layer of the fluid over an adjoining layer. Just now we have seen the definition of that. Yes or no? What are the options they have given? They have given density, kinematics, viscosity, specific gravity. Which is the correct answer? Is nothing but C. So viscosity is nothing but the internal resistance offered by the movement of one layer over the other layer. Direct as per the definition. Okay, very simple. Next, what is this? This one is poise is the unit of. Just now we have derived the units, dimensional formulae, everything we have seen. Where we have come across with poise? Inga undir poise? Yes? 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 No? Dynamic viscosity for mu we have written in case of dimensional formula ml power minus 1 t power minus 1. So this we have written as gram per centimeter second. What is that I have written this? This as poise. Correct? So what is the answer here? Poise is the unit of what? Dynamic viscosity. For kinematic, don't confuse, for kinematic viscosity we have the unit as Stoke. Right? For kinematic viscosity we have centimeter square per second, that is nothing but the Stoke. Don't confuse between poise and Stoke. So poise is the unit of dynamic viscosity. Again very simple. It is 2019 Tnpsc. Okay, right. Next, what is this? What is this? Units of kinematic viscosity are, just now we have seen dynamic viscosity. Units of kinematic viscosity when they have asked Tnpsc 2019. Similar question, SI unit of kinematic viscosity GATE 2001. See the answers. You have to tell me now. Units of kinematic viscosity or SI unit of kinematic viscosity. What is that? SI unit of kinematic viscosity, nu we have written as meter square per second. What is the option we have here? Option A. Very simple, right? So 2 times I have asked, 2 examinations, right? Okay. Next, Okay, right? So I'll stop here. So friends, I think you have thoroughly understood what is that we have discussed. So we have seen what is viscosity, what is the definition, what is the concept, and then we have seen what is Newton's law of viscosity. We have derived the expression for Newton's law of viscosity, and also we have seen what are the various dimensions as well as the units, and also we have seen studied about verena padicho kinematic viscosity patti padichirukkom, and then we have solved some previous year questions also. So very simple. Ipo neenga paathirupinga how many times they have asked from the small topic at the same time it's very important topic, right? So in order to score good marks, again I think advising you, try to practice as many number of questions as possible from this topic. Okay, right? I'll stop here. So wish you all the very best. Thank you.